Okay, now on to the second half where we have a little bit more going on. So we have some things that are going on outside of the base and the exponent. So the first item of business is we've got to get rid of whatever's going on outside of those base and exponent. So for number 7, we have the base and the exponent being multiplied by a -4. So the first thing we want to do is get rid of the multiplying by -4 by dividing both sides by -4. Okay, so we get 5 to the x is going to equal, and then when we do -76 divided by -4, we get 19. And now I say to myself, can I rewrite them so that they have the same base? Nope. So now we have to use logs to solve it. So I'm going to log this left-hand side and log this right-hand side. And I take the exponent and I bump that down in front using that properties of logs. So we've got x times log of 5 equals log of 19. And remember, you should have a log on each side because what you do to one side, you got to do to the other. And then we're going to divide both sides by log of 5 to get that x by itself. So the log of 5s are going to cancel each other out, and we get x equals, and now we do in our calculator, log of 19, close that parenthesis, divided by log of 5, and we get 1.829. Final answer. Okay, so for number 8, we've got something going on the outside of the base and the exponent, so it's subtracting by 7. So since it's subtracting 7, we're going to undo that by adding 7, right? So the 7, it was over on the, problem number 7, it was multiplying by -4, so we divided by -4. Problem number 8, it was subtracting 7, so we add 7. So we've got 5x, 5 raised to the x, equals 37. Okay, so now I say, can I rewrite them so that they have the same base? Nope. So now we've got to use logs to solve them. So we log the left side and log the right side, because what we do to one side, we got to do to the other. I'm going to take that exponent and bump it down in front. X log 5 equals log of 37. All right, and now I want to solve for x, so I'm going to get rid of that log 5, so I'm going to divide both sides by log of 5. So we're going to cancel those log 5s out and get x by itself equals log of 37, close that parenthesis, divided by log of 5, and I get 2.244. Careful with that rounding, guys. And that's my final answer. All right. So now we've got, for 9 and 10, I see e. So those are my special exponential equations. But I've got something outside of the e to the x. So I want to get rid of that thing that's on the outside of e to the x. So I am going to divide both sides by -9.7. So we get e to the x, because the -9.7s are going to cancel out on the left-hand side, equals, and then we do -33 divided by -9.7, and I get 3.40206. All right. And now we want to, can't write them as the same base. We're going to use that special log ln. So we ln the left side and ln the right side. I'm going to take that exponent and bring it down in front. So x ln e equals ln of 3.40206. So now, the ln and the e are inverses, so they cancel each other out and equal 1. X times 1 is just x, equals, and now we're going to do ln of that answer that we had. So it's going to be 1.224. Final answer. Okay. So for number 10, first thing we're going to do is we want to get rid of the thing outside of the exponent and base. So we're going to minus 6. So we get e to the x equals 73. Now, because it's e, it's a special log. So we're going to use ln, my natural log, and I'm going to bump that exponent down in front. So x ln e equals ln of 73. All right, so e and ln are going to cancel each other out to be 1. X times 1 is 1x, so x equals ln of 73. So ln of 73 is going to equal 4.290. I technically don't need the 0, but I'm just putting it there to be a little emphatic about the 3 decimal places. You guys don't need to have that 0 there because it just rounds to 4.29, but just to show you guys that it is 3 decimal places, it's a 0. All right, 4 more. Here we go. So we've got something going on the outside of the base and the exponent. So I get rid of that first, minus 9. So I get 20 raised to the 5.8x equals 94. And then we can't rewrite them with the same base, so we log both sides. And we're going to take this exponent and bump it down in front. So 5.8x times log of 20 equals log of 94. So I want to divide by log of 20 first, both sides, and then that will get rid of it on the left side. So I'll have 5.8x equals, and then we do log of 94 divided by log of 20. And I get 1.516589. And I divide that by 5.8. Remember, we saved this rounding for 3 decimal places to that last step. So divided by 5.8. And I get x equals, I'm going to write that up top, 0.261. Final answer. Okay, on to number 12. I've got something outside of the base and exponent, so let's get rid of that multiplying by -2 first, by dividing by -2. So I'm going to get 18 raised to the x minus 9 equals, and then -58 divided by a -2 is 29. All right, so we've got 18 and 29. There's no way that I can rewrite those as the same base. So I'm going to log both sides and take that exponent and bump it down in front using that property of log. X minus 9 times log of 18 equals log of 29. And now I want to get rid of the log of 18, so I'm going to divide by log of 18 because that's what's with the variable, the x. And we're going to cancel out those log of 18s. So we get x minus 9 equals, and now we do this in our calculator, log of 29 divided by log of 18. And we get 1.16500. Then we add 9 to that. So we get x equals 10.165. Final answer. Okay, last two. And the last two are special ones. They have E. So first thing we're going to do is get rid of the things that are outside of that exponent and base. So we divide by -10. So we get e to the 2x equals -66 divided by -10, which is 6.6. And now because it's e, we're going to log both sides, but we're going to use the special log. We're going to use ln, the natural log, and we're going to take that exponent and bring it down in front. So we've got 2x ln e equals ln of 6.6. So now remember, ln and e are inverses of each other. They cancel each other out when they're right next to each other and equal 1. So we've got 2x times 1 is 2x equals, and then we're going to do ln of 6.6. ln of 6.6 equals 1.8870696. And I divide that by 2. Divided by 2 in my calculator, and I get x equals 0.944. Final answer. All right, last one, almost there. And this will be it for this this is the last set of notes. So we get adding 8. So we get e to the x minus 9. The reason why I added 8 is it's outside of the exponent and base equals 69. Now we're going to use our special log, which is natural log ln, because it's an e. We're going to take that exponent and bump it down in front. So it's going to be x minus 9 times ln e equals ln of 69. All right, and now we've got ln and e are inverses, so they cancel each other out to equal 1. So we've got x minus 9 times 1, that's x minus 9, equals ln of 69. So ln of 69 equals 4.2341. All right, and then we are going to add 9. X is going to equal, remember 3 decimal places, 13.234. All right, and that is it for solving exponential equations where we cannot rewrite them to have the same base. Then we need to use logs. All right, guys, so now you try the assignment for this, and then assignment 3 is literally just posting these notes to make sure that you guys took the notes. All right, and that's it for this week.